Hi, my name is Brian, and I recently created this mini pill scale. I recently started taking a pill every morning, and it was hard for me to remember to take it or to be sure that I had taken it. So this project is my solution and an excuse to play with some new electronics. I added a reminder to my phone, thinking that would solve the problem, but then sometimes later in the day, I would notice the reminder on my phone and think, oh wait, did I forget to check off the reminder, or did I forget to take the pill? The popular solution to this is to fill out a pill box every week, but that just seemed like too much work, and I wanted technology to make that unnecessary. This problem was my inspiration to create a microcontroller and 3D printing project, introducing my solution, a mini pill scale. I wanted a device that would be as minimal effort as possible, both to set up and in daily use. The great thing about this device is that it knows how many pills should be left in the bottle and tells me if I'm on track or not. I see the check mark, so I know I'm right on track. So it uses the weight of the pills to know how many you have left. And that way it knows if you skipped a day or not. If you come back and see that it says one extra pill, then you know, oops, I forgot. So if you see the check mark, you know you're right on track. I wanted to make the initial setup as easy as possible too. So by clicking through these buttons and clicking on Setup Weights, it walks you through how to do it. First wants you to zero out the scale and then place on the empty bottle to get its weight. So after you save the weight of the bottle, you click the button and then it wants you to put 30 pills in. So you count out the 30 pills and put them in. So once you push the button, all you have to do is follow the instructions to place all the pills in the bottle and push the button, and it saves how many pills you have and when your last pill will be taken. One interesting thing to note is that this microcontroller doesn't have a clock in it. And so rather than buying a separate clock, I simply connect to Wi-Fi to know the current time, and especially the date. So how does this work? I'll show you some of the components. The long metal bar running from the front towards the back is the thing that actually does the weighing. It's called a load cell. This one's pretty sensitive to lower weights. It has to have an interpreter, which is this component over here on the side, which turns the weight into electrical signals. And then you'll see that I have a microcontroller under the front cover. This one comes from Adafruit and it has the screen right built in. It includes Wi-Fi, so it was super easy for me. There are a few buttons on the front for the interface, and around on the back there's a fairly large battery that I wanted to make sure it would last a long time, and the one I got makes it last many, many months. Anyway, I put some cool designs on the screen and on the plate and made it easy to access with a removable plate. You can charge it with that port on the left side. I did the 3D modeling in some CAD software called Fusion 360. I'd used it for a few projects before, but I wasn't that good at it, so it was a good learning exercise for me. This is a time lapse of everything that I did. I went through quite a few iterations, as you can see, to build this. I had never done a snap fit cover before. I had never done buttons that press through. Some of them snapped off. Getting everything to fit and including the correct holes for the cord and for the button and for the screwdriver to fit through to be able to screw parts in was an interesting experiment. Then figuring out the tuning on the 3D printer to get the logo printed just right. And then surprisingly, the hardest part of everything tended to be to get the logo onto the flash drive of the microcontroller. For some reason, that took more trial and error than anything. So you can see that I went through 4 major iterations before getting to the final project. So that's the mini pill scale. It's not the most practical project. It cost $50 in components to make this, but I've been using it for many months now actually. Pressing the button every day. It's been very reliable, helping me keep on track, and a great fun project to learn. All the details are in links in the description. If you have any questions, let me know. Anyway, hope you enjoy it. Bye.